Good morning, everybody who's joining us for the first event of University of Bristol Data Week Online 2021. Great day, sun's shining. It's going to be a fantastic week. I'm just going to wait half a minute and then we'll get cracking. Okay, so welcome everybody to the University of Bristol Data Week Online 2021. I'm sure some of you will be familiar with the Jean Golding Institute and Data Week. For some of you, it's going to be a new experience joining us for the first time. This is the fourth Data Week that we've run, annual Data Week, and the second that we've run completely online. And it's a huge pleasure to be kicking off the proceedings today. My name is Kate Robson Brown. I'm director of the Jean Golding Institute. And what I'm going to do today is, first of all, give you a little bit of an insight into the JGI, and then spend half an hour talking about one area of data science and data retention research that I feel is really exciting at the moment, and that is in the space of space-enabled technology, space-enabled data. So first of all, just to let you know, this session is being recorded. We hope you have all read through the JGI Code of Conduct that you were sent earlier. If you could mute your microphone, that would be great, unless you're asked to unmute in order to speak. If you could type us questions, Lily, looking to you, we're using Slido, not the chat box, is that right?
Yes, we are. So I'll post that now so you can access the Slido.
Fantastic, thanks. And then, yeah, if you can complete the registration and make sure that you fill out our feedback form so that we know what you've enjoyed, what you'd like in the future for next year, that would be really helpful to us. And let us know who you are. Introduce yourself in the chat box, send us your name, your role, where you're from. It's great to meet you. And I'm sorry we can't do this face to face, but there's also a benefit, I think, to be had in doing this in a remote way as well. So I'm going to give you a little bit of an introduction quickly to the Jean Golding Institute and Data Week, and then I'm going to talk to you a little bit about solutions for Earth using data from space. So the Jean Golding Institute is one of a number of University of Bristol research institutes that are constituted outside of the faculty structures, so we have an independence. We act as a central hub for data science and data intensive research within the university and through building bridges with partners outside. And we basically connect multidisciplinary experts across the university and beyond. We have these three, you can see in the graphic, we have these three vertical priority areas, which are around societal challenges, data visualization, data realization, and materialization more generally. We've also worked with groups as disparate as musicians and statisticians and artists within that program. And then our third vertical is around reproducibility and data governance. So that includes issues around open data, around responsible research, around governance and consent issues, all those kinds of aspects. And then we have as our fourth priority area, fundamental or foundational research that underpin everything that we do as data scientists. And we deliver those activities with these four main cross-cutting mechanisms. Activities around developing communities, such as this networking today, training and professional development. The Institute acts as a portal for the university's relationship with the Alan Turing Institute, the National Institute for Data Science and AI, and we run a Ask JGI surgery service. So a relatively small team. I just thought I'd show you some faces. We're all hiding behind our laptops at the moment, but here we all are. We have a number of full-time data scientists, research software engineers, as well as coordinators, managers, and administrators. And we are ably helped by our steering group, which is a group made up of colleagues from across the university, all different stages of their careers and from different faculties. For those of you who don't know, there are a number of ways in which you can engage with the JGI. So obviously a good start is coming along to events like this, but we also provide Seedcorn project funding once a year. The call normally goes out in November. That's what we're aiming for. And those projects, that funding is for relatively small, modest projects to get new and exciting areas of research going where there's a multidisciplinary collaborative aspect to it. We run our data science advice service, Ask JGI, which is for all researchers in data science and data intensive research. And there's an email contact that I'll give you at the end. So we provide, in some senses, data science consultancy with a small c for both internal and external partners. We put on annual data competitions, and I've got a little bit more information about the last one that we ran on that. We will facilitate interdisciplinary workshops. So if you have an idea for a workshop that you think would be suitable for our kind of audience, let us know. We might be able to work with you to develop that. So as I said, we are the liaison with the Alan Turing Institute. I'm the Turing University lead. Patty Holly is the University Liaison Manager. We work with the Turing very closely to develop all kinds of activities, for example, around PhD enrichment, around talks, helping to support the groups of fellows. We have around 30 fellows in the University of Bristol from the Alan Turing Institute, so we work with them as well. We increasingly we find ourselves engaged with liaising with our external partners, and welcome to you if you're on this call today who would come into that category. So this is where we help colleagues within the university engage with external organisations of all kinds, companies, NGOs, public policy makers, the councils, to develop research relationships that can benefit the agenda of data science, data intensive research and AI. And we put on lots of data science training throughout the year, but obviously, as many of you know, this week we've got a particularly strong set of events that you might be interested in that regard. So just a few more examples of JGI activities. We have 2 international partners. So the first is with the Institute of Statistical Mathematics in Japan, and that's really focused on foundational methodologies. We've had a number of joint events with them. So for example, we host a seminar series back in 2020. We ran a kind of online conference around methodologies and applications of geometric data analysis. We had good attendance from both countries, including colleagues from commercial partnerships, which is great to see. We're planning a PGR, that's a postgraduate research PhD student, essentially poster conference in October 2021 to get those early career stage researchers together. And we're hoping for a joint workshop for May 2022. You never know, that might even be face-to-face. That'd be something to look forward to. And our second international partnership was with Strathmore University in Kenya, in Nairobi. With them, we have a number of collaborative research projects focused at Bristol with colleagues in the vet school and Rothamsted Research, and more widely with the International Livestock Research Institute, ILRI, who have a Bristol office but have a very large infrastructure in Nairobi, and of course the Turing as well. And that project supports PhD students, one currently and one soon to start. We work with them to develop co-produced talks and training, and are going to be contributing to their Strathmore Data Week, which was modelled on ours at JGI, which is being scheduled for September 2021. And we partner with them on an event, for example, at the University of Bristol International Festival just a couple of weeks ago. They're both really, really productive relationships, and many of our colleagues from those institutions are joining us remotely as part of Data Week as well, which is great to see. To give you an example of the kind of projects we've funded with Seedcorn funding, over the years we've funded around 42 Seedcorn projects. In 2020 we funded 12. 6 were roughly in health, 2 in social sciences and arts, and 3 in data science for science, and 1 engineering, but all of them were kind of collaborative and multidisciplinary. We also ran a postgraduate competition in 2020, and we haven't been able to do that this year, but we are aiming to do that again next year, because we found it was a really great way of reaching out and engaging with those early stage, early career researchers in our fields. And just to give you a sense of some of the ongoing projects that have partly arisen out of those kinds of collaborations, here's just a few. And I'm not going to run through them one by one, but you can see from this list that actually they engage with colleagues across the university in all faculties, from translating science fiction in the arts faculty and in modern languages, through to analysing flood data with geographical sciences, with psychological science around understanding kind of variability in response and reproducibility of research, with the What Art You Seeing project, which is a collaboration between the data science team in JGI and the Alan Turing Institute, with colleagues from other Turing University partners, the University of Warwick, and also with industrial partners. So for example, here with GraphCore down the bottom of the page, and Jonas Rademacher from physics, helping to develop solutions based on the GraphCore hardware for potential application at CERN. So all kinds of projects, and what they have in common, I think, is their kind of ambitious scope and multidisciplinary team. So if something there rings a bell with you, if you think, oh, that would be interesting, do let us know, and we'll make sure that you are aware of our call as soon as it comes out. The data competitions are a really fun aspect of how we develop the community. So the last one we ran was with the Food Standards Agency, and this was looking at risks associated with the movement of food around the world. It was a data visualization competition, and the winner was actually a registered PhD student, Robert Dyer, from engineering maths here in the University of Bristol. And that project went on to be presented at the FSA, and I know that they've been interested in implementing some of the outcomes from it. So it's a great result all round. We're now in discussion with Geovation about the next data competition, which we hope to run towards the end of the year. Throughout the year, we have mechanisms that we put in place to support ongoing research development. So, for example, we have data science co-working sessions, one on a Tuesday afternoon on Slack, and one on a Thursday morning, I think it is, on Discord. And this is a place where you can come and join a community, which is particularly important, I think, working in the current environment. You know, I'm at my kitchen table here. I'm sure many of you are. But this is an environment where people can come together and work in an informal but really supportive way on their own work, make some contacts, maybe some friends, and share good practice amongst the group. So those have been really successful this year, really taken off during lockdown. We also support the work of kind of reproducibility and open analysis and open data in R. We have our data visualization interest group that meets regularly throughout the year, and has a mixture of talks and workshops and other kinds of activities. We have our new data ethics club, which is led by Nat Thirlby, one of our data scientists, which has been hugely popular, where a community across the university and beyond come together. So sometimes it's a journal club, sometimes it's a talk, and that's something that has really taken off with this way of working in this remote environment at the moment. And we're developing a handbook of tools and practices which we can share with UA, which we hope will act as some kind of FAQ as well. So Data Week Online, welcome. You're all aware of what we're doing. You're here, you've registered, which is great to see. But I think what I just wanted to say was that we really make an effort when we're designing Data Week to reach out to the kinds of events that we think could engage people who are interested in all aspects of the data pipeline, or this infographic shows sort of a data cycle. So if you're interested in data capture, there's something there for you. For example, we have an event with Sphere looking at capturing data in the home. We have an event with EBI around health data. If you're interested in analysis, then you might want to come to some of our training events that we're running with ACRC, a strong partner on Data Week. You might want to learn some coding, some Python. You might want to hear a talk about some interesting new analytical platform that you could use. And in terms of communication, and you're interested in data visualization and the communication of data science, then, for example, come along to our screening of Coded Bias later in the week, when we'll be able to see the film and then discuss the aspects of kind of communication, trustworthiness of systems that arises out of that film as well. So we do make an effort to try and have events that speak to all these different aspects of what it means to be a data scientist or somebody working in the area of data intensive research. And you would have seen the schedule, but I want to put it up anyway because it's 40 events over 5 days and represents a huge amount of engagement throughout the week. This has been planned for really a year since we put down our pens on last data week. But because we've had a year to get used to working in this environment, we've been able to put on a lot more opportunities for you to engage with us. And I really hope there's something there of interest for all of you. And just a quick shout out to all our partners that have made this happen. You know who you are out there, but we're really grateful for all the engagement that you've given. And I hope that you enjoy the events as we go through the week as well. So I'm going to spend the rest of my time talking about solutions for Earth using data for space, because this is an area that I think is increasingly significant to how we work as data scientists and people involved in data intensive research. And it's also pretty topical because on Friday, I was lucky enough to be invited, but on Friday, the world's only company-owned deep space antenna was officially opened at Goonhilly Earth Station in Cornwall. It was a G7 related event. There were all kinds of people, international, there were ministers there, international companies. It was a great, really exciting event. And it struck me that the buzz around that event, the excitement surrounding that event, is evidence of the ever-growing importance of space technology to many aspects of our lives. And so I thought it might be interesting just to kick off this data week with my own reflections on the opportunities and challenges that this technological revolution that we are living through, but sometimes feels a little bit invisible to many of us maybe, but what this is opening up to the worlds of data science and data intensive research. And you might ask, well, where's my interest in this? So my own research area, as some of you know, is in bone microstructure, biomechanics and applications. And the development of methodologies for data capture, so imaging particularly in image processing, and the computational modeling of those kinds of complex hierarchical 3D data sets. In terms of the space sector, my background and perspective is drawn from the space life and bioengineering areas, and more recently through translational projects between these domains and other disciplines within engineering. And part of that has given me the great privilege to be parts of teams which are developing payload experiments for low Earth orbit deployment. So through that, I'm currently chair of the UK Space Life and Biomedical Sciences Association, and we've just published our position paper, white paper, Why Space, UK Life and Biomedical Sciences, where we brought together a community from across the country to give us their reflections on where they thought the real commercial and research opportunities were in low Earth orbit experiments. I've also been lucky enough to be the University of Bristol lead and co-investigator for the UK Space Agency funded West of England Space Hub, and our activities involve mapping research and commercial landscape for the region and co-producing a development strategy. And we've also got some fun projects that are going on at the moment. So for example, I'm a named contributor on a science museum project called Culture Space towards a better understanding of space exploration, led by Doug Millard. And that's all about redeveloping the space exhibitions in the Science Museum itself. So having a new gallery and a new exhibition for Mars as well coming up as well. So that's really exciting. And together with Ian Hamilton and team here in the University of Bristol, working on a European Space Agency funded Euro material aging program, which will provide us with an opportunity to fly an experiment. Sorry, that's a lawnmower outside my house. To fly an experiment next year to expose some exciting new materials to the harsh environments of space. So I've been working in the space sector really for 20 years, 25 years, but never in my working life has there been a more exciting time to be engaged in this sector in the UK. We've seen the UK R&D roadmap place the space sector high on the agenda. There's a new National Space Council developing a national space strategy, which should be published in the summer. That's the promise. The recently launched Space Command, launched back in April, and the AI agency associated with that, which I think is mostly going to be working in the area of space situational awareness. There's the launch of the first space engineering technician apprenticeships in England, the beginning of next year, and a nanosat competition, which was launched at G7 just a couple of days ago, which will provide funding for a multidisciplinary team to develop a new satellite solution. So it's a really exciting time. There feels like there's a lot of momentum in this sector, and a great deal of it relies on the data science and AI and data intensive research communities of which we are a part. Even in our own region, we've seen the development of the West of England Space Hub. So there are in fact 7 new regional space hubs. Our alliance comprises a consortium of the universities in Bristol and Bath, the National Composite Centre, the NCC, the Centre for Modelling and Simulation, CFMS, and industrial partners. And the aim of these initiatives is to give regional consortia the opportunity to position themselves at the forefront of space-enabled innovation and inclusive growth. And it sees experts and business leaders uniting to identify and showcase existing strengths, and also set a future strategy which will maximise space potential regionally. And as part of our mapping system, we identified a really strong number of companies in the region that either are working in the space sector or expressed a desire to do so. These are both upstream, so for example, work around Earth observation, space science and exploration, as well as downstream, using satellite data to support, for example, climate change monitoring and mitigation. So this is a really exciting time, I think, to be thinking about how data science and AI expertise that we have in the university can speak to these kinds of activities. And these are some of the companies that have contributed, and organisations that have contributed to the West of England Space Hub and will continue to do so. So in terms of space-enabled data, also on the international stage, I just put this slide up to give you, for those of you who don't know, what the Lunar Gateway orbiting, the Lunar orbiting facility, which is already in development, and who's doing which bits of it. In terms of space-enabled data from the international side of things, we've got the Artemis program coming up, which is the shift to attention to missions on the moon, recent outer space treaty, the Chinese having successful lunar deployments recently, European Space Agency roadmaps, the Space roadmap, for example, going up to 2030, developments at the European Space Agency data center in Madrid, and of course the impact of Brexit encouraging us to develop collaborations further afield than ESA. In NASA, over the past 5 years or so, we've seen data science and data-driven approaches have considerable adoption and interest, and there are many current activities across NASA centers, with several key efforts focused, for example, at JPL, which is leading efforts to drive the adoption of digital and data technology across all their sectors. They've run about 50 pilot projects in data science over the last few years, and in a very recent call for projects, I heard they received over 60 new proposed concepts. They're increasing investments at NASA in pushing new observing systems that include AI in space, and that's their phrase, and the integration of ground systems to bring together data archives, science modeling and mission planning together with cloud-based services to close the loop and create a much more dynamic ground system that is event-driven and can drive a constellation of sensors. And these kinds of initiatives are a response to the opportunities presented by the ever-growing data flow from space and space centers. And they're increasingly driving an agenda of what has been dubbed Space 4.0. This vision aims to transform the space sector to improve efficiency and productivity, primarily through development and integration of digital technologies such as artificial intelligence, simulations, the cloud, Internet of Things, big data analytics, and augmented reality and virtual reality. So from the perspective of the UK and our communities, it's a really good time for us to be thinking about our ambitions for digital and data using these space-enabled technologies. Because finally, we have a decision-making body able to develop and implement national strategy for the space sector. There's a drive to build strategy around the development and regulation of commercial spaceflight in the UK. And there's a general acknowledgement of the value of the space sector to the economic growth of the UK and interest in how those opportunities can be commercialised. For example, around the Artemis programme, spaceports and spaceflight development. The UK is developing their own spaceports. We have a regulatory framework for the space sector on the horizon. There's plans for UK spaceflight, commercial flights, and lots of opportunities for spaceflight operations and manufacturing. And all of these ambitions will require strengthening in international partnerships and collaborations, as well as building a strong workforce that is appropriately skilled. And there's a big skills piece associated with this work. So for example, upskilling people so that they can be involved in mitigating the impact of space weather and space debris, maintaining security and improving telecommunications and connectivity. So one way to think about the scope of our ambitions for data science and digital in the sector, because it can feel quite complex, is I think to divide it into 3 domains. So a low Earth orbit domain, a lunar domain, and a Mars and beyond domain. So let's kind of break it down into those sections. This is a picture of the Bartolomeo platform on the International Space Station. And I just I put it out there as a shameless plug. The Bartolomeo is an exposure platform, and you can see little boxes on that RAM side of the ISS there. So they're boxes that you can put materials in or experiments in for exposure to the harsh environment of space, and it's on the Bartolomeo, which Ian Hamilton and his team, which I contribute to, where those materials are going to be launched next year. So let's think about science and space then, and the data and the digital challenges and opportunities around that. So experiments leveraging the benefits of microgravity environments, which are deployed on the ISS, are generating ever larger and more complex data sets, much of which requires streaming for real-time data capture and data analysis. And demand for access to these experimental platforms is growing strongly. In a recent call run by ESA, it generated around 300 applications, and this was for a call without necessarily an immediate funding stream. So facilities to be free at source, but without a funding stream to go on to do the fundamental research. And experimental hardware now often has a requirement to be driven remotely or function autonomously. There's a need also to limit astronaut time and the complexity of training requirements that implies. Spin out of Airbus, Yuri, for example, is working on projects which receive data points from ISS experiments, and they are able to remotely control those to a limited extent. And this kind of activity will significantly increase in the coming years as researchers are demanding more real-time data from on-station analysis tools and remote controls. And this demand is also driving the development of a novel ecosystem of commercial low Earth orbit or LEO solutions, which are uncrewed and offer a variety of mission deployment systems and flight durations, which could well bring down the cost of access and open up opportunities for the supply chain industries that support these. All these systems on the horizon, kind of in reality now are on the horizon, will need data infrastructures, data engineering solutions and architectures, software development and new analytics. And in many ways, we're really well placed, I think, in the UK to take advantage of these opportunities, given our existing wealth of expertise from the related sectors. This is just a slide of the Sentinel satellites. And I think, to my mind, there are 5 main categories of space technology generating data that have become ubiquitous in our daily lives and our research. And they are satellite Earth observation, satellite communication, satellite positioning, PNT, microgravity research, such as those experimental platforms, and the opportunities for technology transfer. And we're seeing ever more ambitious missions involving space technology to increase coverage, communication speed, efficiency of analytics, and to leave a societal benefit measured through health, wealth, and prosperity. One particularly exciting area for development is on onboard processing. So if you take the example of Earth observation, we as individuals might be interested, say, in flood mapping or quantifying ice, but there could always be some recording which is suboptimal. So for some satellite systems, for example, because of cloud coverage. There's long been an ambition to triage at the point of data capture and release downlink bandwidth and review time. ESA recently estimated that sensor capacity to generate data increases by a factor of 100 every generation, but the capacity for downlink lags behind, increasing only by a factor of around 5. So onboard processing, sometimes called AI at the edge, has begun to turn around this challenge. And the benefits of doing so in terms of latency reduction, autonomy, and data filtering are significant. But because of the drivers towards low power consumption, low mass and volume, and resilience to radiation, some of the first developments have been in the integration of commercial grade processors and resilience infrastructures around them. Very recently, for example, we've seen Intel announcing their installation of an AI vision processing chip into onboard computing across onboard a European Space Agency CubeSat. And this is part of a much wider trend towards increasing computational power on orbiting facilities in order to process raw data from imaging satellites. Back in September, we saw the launch of ESA's PISAT-1, which is a 6 new CubeSat containing a hyperspectral thermal camera to monitor polar ice and soil moisture with a vision processing unit, or VPU, to filter through the high throughput data stream. This computing hardware requires not only resilience to survive the harsh environment of space, but also they must be efficient and low power, challenges which have spin-outs for terrestrial applications as well. PISAT-1 might be the first of a series of collaborative missions, and there's a healthy industry developing around this opportunity. SMEs are exploring how to embed edge computing into satellites, overflying data centers, or whether this can be achieved using CubeSat designs that are quick to assemble and relatively cheap to deploy. One interesting example is that called Capella Space, which has incorporated an NVIDIA processor into its synthetic aperture radar, SAR radar satellite, which allows limited onboard image processing before full downlink is completed. The UK, as with many other spacefaring nations, is looking to horizontal and vertical launch. So for the UK, that's in Scotland, Wales, and just down the road at Newquay in Cornwall, Spaceport Cornwall, who will have their first launch using in the collaboration with Virgin Orbit just the spring of next year. This will really help to reduce the cost of deploying small satellites. If the trend continues, we could see other imaginative ways of integrating compute within satellite ops, which could make the vision of data centers orbiting the Earth and later the Moon a real reality. This would also enable more flexible operating systems. Satellites could be designed to have more than one purpose, hosting hardware platforms and software solutions for more than one set of users. Some companies have already publicized their plans to do this already. In the US, a company called Orbit's Edge is exploring the deployment of off-the-shelf rack mount servers by integrating them into the payload volume of a satellite. The aim there is to upscale computing capacity for commercial space activity to process data at the point of capture, as we said, including cleaning, aggregating data from multiple sources, as well as analysis. And one of the interesting things about this proposal is the deployment of communication systems between satellites, sometimes using laser systems. This could facilitate onboard processing for data captured where an Earth station data center is out of reach. It might even be possible to send processed data to users in the field, bypassing the need for expensive Earth station downlink. Several commentators are calling this processing above the clouds, and there's understandably interest growing from a range of user and customer communities, including research, fintech, and creative industries. The servers Orbit's Edge have announced they're using are HPE ER8000, and HPE has experience of flying servers in LEO in low Earth orbit before, for example, on the ISS. But the high exposure to the harsh environment of space implied by the satellite deployment poses all kinds of new challenges. For example, power is a major concern. Solar arrays can generate power, and presumably new configurations of batteries might be needed to maintain function while satellites are in shadow. Thermal cycling is another big issue, and there'll need to be some means of cooling operating hardware. But there are other challenges as well. How do we protect such hardware systems from solar flare events or microballistics from space debris? Related to this, we maybe should remember that all the IT technologies which are part of Industry 4.0, AI, the cloud, big data, IoT, are transforming the way Earth observation data is being processed, analyzed, and used. This transformation does not necessarily mean using only Earth observation data to draw insights, but integrating different data sources to draw out analytics using artificial intelligence and machine learning. More acquisition capacity and the combination of Earth observation data with other sources of information, augmented with digitalization, will enable the triage and analysis of Earth observation data, bringing it into the decision-making process and accelerating the deliverables of like actionable insights to users from such a wide variety of markets. And from a European perspective, especially concerning the Copernicus program, we know that new data platforms are being developed to receive, to process, and to archive the massive volumes of satellite data collected from the Sentinels and other contributing commissions. These data platforms are established on the cloud and work with AI and machine learning, enabling the development of new applications in the EO sector. So many have argued that this accelerating digital transformation in the space sector will bring with it new business models for the space industry. For example, there might be a pay-per-use business model that could open up opportunities for startups to engage. If a marketplace develops that it has as its core new and effective data platforms that offer access to EO-facing companies, there's a huge opportunity for value-added services, more so even if that access is free at source. The effect of this could be to facilitate a really rapidly growing ecosystem of data providers, brokers, and users of Earth observation information. And what about going back to the suggestion that multiple users might share satellite operations and data processing? This would lower operational costs and open up space applications to new markets and audience. A company based in San Francisco, Loft Orbital, is proposing just that, and high-profile customers include, for example, the government of UAE and the European satellite Eutelsat. They're all attracted by the idea of an orbit-based computing infrastructure, but as a service. The customer payload will be hosted on board the satellite, the control will be via a web portal, or the customer could be one step away and simply focus on the application. In summary then, we could all well expect to see reduced costs for manufacturing and launch, a rich and diverse population of private sector companies involved, and innovative new business models transforming in the Earth observation industry and significantly improving access. The integration of digital and data science solutions is central to this becoming a reality. So if we take one step out further to lunar missions then, I guess I have a particular interest in this. I was born in 1969 and almost feel as if the excitement of exploration of the moon is somehow built into my DNA. So I've been watching it for a while, opportunities there. There hasn't been much in my lifetime, but things are changing really fast. Over the past few years, the international momentum has grown, has really been renewed around lunar missions, to the point that today, pretty much all the spacefaring nations are committed to some really significant initiatives, many of them collaborative and increasingly involving the private sector. And anyone who watched last year's NASA R&D conference, and if you're vaguely interested, I would say for this year, it's in the summer, normally July or August, I would thoroughly recommend it if you want an insight into what's kind of happening in the space sector. But if you did watch that last year, you will have heard that, received that message loud and clear. But as we look deeper into space for future deployments, the challenges obviously increase. Challenges in terms of data science and data intensive research increase. Outside of the magnetosphere, the radiation damage risk increases. Physics is not on our side, and communication lag becomes ever more problematic as bandwidth is constrained. The need for onboard computing is obvious for all kinds of deep space missions, whether including astronauts or not. Autonomous vehicle operations, computer vision processing, and data analysis to support autonomous decision-making and data triage will all be critical to mission success. For example, the Artemis program, Artemis of course is a twin of Apollo. In December 2017, the US president called on NASA to lead a human return to the moon and beyond, to be achieved through partnerships with commercial and international organizations. In 2019, this ambition was accelerated, calling for a mission to send the first woman and next man to the moon within 5 years. NASA is implementing the Artemis program to achieve those goals, aiming to achieve a human landing by 2024. I have to say, I think that sounds optimistic now, but while simultaneously working towards sustainable lunar exploration in the mid to late 2020s. So it is on the horizon. This is really ambitious. But the most recent news of the Space Launch System, the SLS rocket and Orion spacecraft nearing the end of testing and development, suggests that the technology is in place to achieve human lunar orbit at least. The human landing system is in development, and the orbital gateway station, which I showed a picture earlier, has the power and propulsion element and the habitation and logistics outpost all planned for launch together in 2023. So less than 2 years in the future from now. The commercial partnerships underpinning these developments are real. The lander is commercially developed. New spacesuits are in development that will incorporate sophisticated communications and life support systems with a lot more integrated, automated data capture for clinical use as well, which is interesting. On the Gateway, they'll be able to conduct research using novel experimental platforms and take multiple trips down to the surface. There's a really strong drive towards interoperability of the components and digital and data platforms, and NASA is already working with Artemis providers to ensure spacecraft are built to international interoperability standards. Some countries are already stepping into claim R&D territory. So the Canadian Space Agency has committed to providing advanced robotics for the Gateway. ESA plans to provide the international habitat and the Esprit module, which will deliver additional communications, and the science lock for payloads and CubeSats and refueling. The Japanese Aerospace Exploration Agency, JAXA, will contribute habitation components and logistics resupply. The Russian agency, Roscosmos, has expressed an interest in cooperation on Gateway. And at the Lunar South Pole, NASA and partners will develop an Artemis base camp to support longer expeditions on the lunar surface. Planned base camp elements include a lunar terrain vehicle, which is an unpressurized rover, a habitable mobility platform, which is pressurized, a lunar foundation habitation module, power systems, and in situ resource utilization systems. And this incremental buildup of capabilities on and around the moon is seen as essential to establishing long-term exploration of Earth's nearest neighbor, and also preparing for the longer-term human exploration of Mars. And everything I've described is reliant on robust, trustworthy, innovative, digital and data-driven systems and processes. Similarly, Orion and the European Service Module will return humans to the moon and take advantage of the new technology for human space transportation. Orion, the spacecraft, is a NASA deliverable, while ESA is providing the surface modules that will provide propulsion, life support, power, air and water, and control the temperature in the crew module. The Heracles mission could launch in 2028, which will allow us to gain knowledge about human-robotic interaction while landing a spacecraft on the moon, collecting samples with a rover operated from the Lunar Gateway, sending samples back to Earth. And there are huge challenges to these ambitions in terms of tech platforms, communications and analytics. Having said that, the moon is possibly much less constrained than Mars if all these full plans are realized. On the planned lunar deployments, there could be a rich and sophisticated comms system available, and the physics is much better given the short distances in play, relatively short distances in play. There are concerted efforts underway to put high bandwidth comms around the moon to enable a whole collection of service and orbital activities, and digital infrastructure will make a massive impact on the possibilities for exploration there. That said, there will still be the need for autonomy for some of the operations, and it will also act as a good staging post or trial for the tech on the way to Mars. It'll be a really exciting showcase for both extraterrestrial digital comms and robotics, and will set the scene for complex partner development that will be needed to include, for example, IP and data sharing, use of resources and safe operations. So here we have some of the slides from the ESA holding page on those lunar explorations, including parts of the Gateway and surface habitation modules. So finally, stepping out to Mars, and here the challenges to exploration are extreme, and we need to return to our first principles when developing digital and data solutions to underpin missions. The constraints are huge in terms of deploying technology because there's a lack of communication infrastructure, and therefore the ability to get data to and from the planet in a timely way or provide database services such as GPS. The cost is exorbitant and the physics limits what's possible as a research and development community. So we need to work together to overcome this with other kinds of solutions, such as autonomy technology. And the ambition in effect opens up opportunities to the AI, robotics and computer vision research communities around, for example, autonomous mobility, science autonomy. Given the data constraints and inability for remote presence on Mars, we'll need to be able to detect and identify targets of interest on behalf of the science and engineering team. There's a project in process to address this using what has become known as science autonomy tech, which uses a variety of computer vision and ML solutions to achieve that. And in terms of orbital Mars exploration, here the challenge lies somewhere in between lunar and Mars surface in terms of digital and data complexity. There's a plan for a data processing facility on Mars, for example, involving the classification of huge high-rise images of Mars in minutes using machine learning. And this is planned to allow geologists and engineers to better interpret terrain and make decisions on landing site selection, for example. So summarizing these three domains, low Earth orbit, Moon and Mars, there are common themes here around the lack of one type of digital capacity, for example, real-time comms and infrastructure, and the bottleneck of real-time high bandwidth data provision using another, robotics, autonomy, AI, etc. The other constraints are much older computational resources and energy constraints, and also limited sensor options, which greatly impact our ability to deploy, but also make the work interesting. And here are some of the pictures just grabbed from the ESA and NASA websites of some of the tech that's we're all familiar with at the moment in the Mars missions that are ongoing. So I hope I've shown some of the range of opportunities that are developing in these domains and given a sense of the huge momentum growing in the sector. This really is the time to get involved. And as a final note, I think some of the most excitement and impactful applications of digital technology and data science developed for space applications are, of course, terrestrial. We continue to see more and more opportunities and direct examples of methodology transfer across science disciplines. And there are many application areas with huge opportunities for significant research and development. Priority areas would include, for example, space and weather and space weather monitoring, climate change monitoring, nowcasting, agri-tech and smart farming, public health monitoring, telemedicine, medical health interventions, interconnected med tech and monitoring supporting precision medicine and personal centered care, and of course, disaster relief. And the benefits of these data science above the cloud solutions are not confined to the commercial world. There is a global movement to harness the power of space technology as a tool for social good, sustainable development, and the UN Sustainable Development Goals. And to achieve this, we need to think in new ways, engage with non-spacefaring nations, and co-produce multidisciplinary projects that incorporate not only satellite engineering and data science, but also systems design, social science, and the arts. The worlds of space technology and data science need to come together with development leaders, national and local governments, agencies, NGOs, and multilateral organizations to identify opportunities to apply space tech and space-enabled data in their decision-making, whether the scope of that be smart government, improving public services and healthcare, serving local challenges, addressing climate change or weather events, or improving well-being through cultural activities. There's really good evidence that this works. We could look to the UN Office for Outer Space Affairs and all the great work they support towards fair access to all for the benefit of space-enabled technology. UK Space Agency has recently announced a collaboration with this programme to support sustainable space activity. We could look to the grassroots development of collaborative space consortia and regional agencies, such as the 20 space agencies and space research centres across Africa, who are developing both bespoke solutions for local communications and Earth observation challenges, as well as building collaborative relationships with external partners. This includes programs such as the Africa Data Cube or Digital Earth Africa, which is a collaboration of 5 primary partners, NASA, the UN, and a user community of researchers and policymakers, tackling challenges as diverse as illegal mining, smart agriculture, and flood mapping. So I think we need to take up the energy that exists in the commercial space sector and open it up to leave a benefit for communities around the world. This will require not only improved infrastructure for cross-sector collaboration, but also some bespoke research to design space systems that are both accessible and sustainable, and that speak to the relationship between technology design, responsible and reproducible data science, and social justice. So all that remains for me is to say thank you to everybody that has facilitated this work and the work that we're showcasing throughout Data Week. Do stay in touch with us, and this is a slide that shows lots of ways in which you can do that. Have a look at what else is on in Data Week. If you've got a query, let us know via our Ask JGI email. Tweet us on @JGI Bristol, subscribe to our newsletter, join us in the blogs and contribute to blog. And we'd love to keep in touch with you.
Sorry to interrupt. Are you happy to answer a couple of questions?
Yeah, sure. Have we got time?
We have a couple of minutes.
Yeah, go.
The first question, is there a research group of projects focused on natural language processing, having interest in NLP? And would love to be a part of a project group like this. So actually, that is a very specific question. So if you can email us to jji-admin at Bristol, we can respond to that. The email address is in the chat.
So I can just really quickly, I know there's a lot of interest in natural language processing. We've run a couple of events recently where this has come up.